Now let's move on to question 2, right? The first question, 2.1 says the first term of an arithmetic series is 7, right? You know that for an arithmetic the first term is a, so a is equals to 7, and the common difference d is equals to 5, right? And the series contains 20 terms, so meaning n is 20, right? It contains 20 terms. 2.1.1, calculate the sum of the series. So the sum of this series S20, right? Or let me write the formula first. Sn is equals to n over 2 into 2a plus d into n minus 1. Yeah, so S20 is what we are calculating, right? Because this series contains 20 terms, so it's gonna be 20 over 2 into 2. A is 7 plus d, d is 5, into 20 minus 1. Then you put this in your calculator as it is. So this is 10 into 14 plus 5 into 19. This is 1090. The sum of the first 20 of the 20 terms of this series is 1090. 2.1.2, the original arithmetic series is extended to 75 terms. Calculate the sum of these 75 terms. The sum of these 75 terms is 14,400. Using sigma notation, write down an equation for the sum of the terms that are added to the original series, right? So the original series was because the first term was 7 plus 5. How much is 7 plus 5? That's 12 plus 5. 12 plus 5, 17 to 20 terms, right? I don't know what was the 20th term, right? Let me just write T20 there, right? So when you add all these numbers here of the original series, the sum was 1020, right? Now we are extending it. We are adding T21, T22 up until T75, right? So now the sum of this part from T21 until T75, it's the one that we need to represent using a sigma notation, right? But then because now they gave us the sum of all the 75 terms from here till there, they said the sum is 14,400, right? 14,400. So to get this part here from T21 to T75, we will subtract these two numbers, right? So 14,400 subtract 1090, not 1020, 1090, subtract 1090, then you get 13310, right? So now to represent this in sigma notation, it will be sigma, right? The top number is the position of the last term, right? So that's position 75. So position of where we start at 21, we write it at the bottom. Then here you have to write the pattern, right? So now we need to get Tn, right? So of this series, so we know that Tn is equals to a plus d into n minus 1. We know that a is equals to 7, d is equals to 5 into n minus 1. If we simplify this, we'll have 5n minus 5 plus 7, that is 5n plus 2, 5n plus 2. So we can write 5n plus 2 here, 5n plus 2, right? They said we should write an equation. If they said they wanted an expression, we were gonna leave it like this, right? This is just an expression. But then now they say they want an equation, there must be an equal sign. So what does this equate to? It equates to 13310, right? And this is your answer here. Yeah. So now let's move on to 2.2. Question 2.2, the sequence of the first difference of a quadratic pattern is 1. This is the sequence of the first difference, 1 3 5, right? 1 3 5. This is the sequence of the first difference, right? You know that a quadratic pattern, right? It goes like this. You have T1, T2, T3, then T4 there. So the difference between T1 and T2, it gives us 1, right? The difference between T3 and T2, it gives us 3. Then the difference between T4 and T3, it gives us 5, right? So the sequence that they give us there, 1 3 5, it's this one, right? This is where it comes from. So be aware that the first the second and the first term of the quadratic sequence, it gives the first term of the linear first difference. So yeah, they then say 2.2.1 if T99 of the quadratic pattern is 9632, calculate the value of T89, right? The value of T89 of the quadratic pattern, right? So now we can make use of this linear sequence, right? Because we know that T99, right, of the quadratic minus T98 of the quadratic, it will give us let me call it difference, right? The pattern, let me call it D. So it will give us the difference number 98. It will give us difference number 98. From here you can see, okay, from the sequence T2, right, minus T1, it gives us D1. It gives us the first term of the first difference, right? So similarly, T3 minus T1, it gives us D2, difference number 2, right? So now we need to find, because now they gave us T99, they are looking for this. So it is also possible for us to get D98. We can just find that D98 using this pattern 1 3 5. Yeah. So we need to find Dn, right? So Dn is equals to A plus D into n minus 1, right? So we need to find term number 98 on the first difference, right? So D98 will be equals to the first term here, A is 1, plus D3 minus 1, that's 2, into n, it's 98 minus 1, right? This will then be 1 plus 2 into 98 minus 1, that's 97, that's 195, right? D98 is 195, so we can substitute to find T98 then. So we know that T99 minus T98 is equals to D98, ne? So T99 ke bokae? T99 ke 9632, right? Minus D98, that's 195. No, minus T98 we don't know, equals to D98, 195. Then now we can then solve this and make it the subject of the formula. So T98 will therefore be equals to 9632 minus 195. 9632, that's 9437. That's term number 98 of the quadratic pattern. Now let's move on to 2.2.2. If it is further given that the third term of the quadratic pattern is 32, determine the general term of the quadratic pattern, right? They give us the third term, ne? So now we need to express the third term in terms of the letters A, B, and C, right? So you know that Tn is equals to an squared plus bn plus c, right? So it means that T3 will be equals to A into 3 squared, right, plus B into 3 plus c, right? So 3 squared, that's 9, gonna be 9a plus 3b plus c, right? But then they gave us that t3 equates to 32, right? So 32 is equals to that, né? So now let me write that again. You know that it's t1, t2, t3 there, I get. So t4, I get. So yeah, they gave us the differences, ne? They gave us the differences. So you have the differences as 1, 3, 5, right? That's the first difference, right? Then the common difference will be 2, right? So now you know that to determine equation quadratic number pattern, this equates to 2a, right? So 2a is equals to 2, right? Then it means that a is equals to 2 over 2, that's 1, right? And this one, this is 3a plus b, right, equates to 1, né? So 3a plus b is equals to 1, but a is 1, so we have 3 plus b is equals to 1. Then b will be 1 minus 3, that's negative 2. Then now this t1, it equates to a plus b plus c, but we don't have this t1. But there's an equation that we made that has all the letters. We can make use of this equation there. You see, we can make use of this equation. So 32 will be equals to 9a. A is 1 plus 3b. 3b is negative 2 plus c. Plus c there, right? So c is the only variable left. Now we can transpose everything, so it's gonna be 32 minus 9 plus 6 is equals to c. 32 minus 9 plus 6, 32 minus 9 plus 6, that's 29. So c is equals to 29. Therefore Tn is equals to n squared minus 2n plus 29. That's our Tn there.